So we've looked at calculating the area above and below the x-axis. What I'm going to do here, I'm going to pose you a couple of questions. What I want you to do is pause the video, have a crack at these questions, and then come back and check your answers. Here you go. I want you to calculate the area of each curve between the given limits there. So for the first one, it's y equals x cubed minus 6x squared plus 11x minus 6 between 1 and 3. And the second one is y equals x cubed minus 6x squared plus 8x between 0 and 4. So pause the video and have a ping at those. So the first one, y equals x cubed minus 6x squared plus 11x minus 6. So remember when we talked about these before, there were a few sets of steps we had to do. First one, we had to discover the roots. So we need to know if this crosses the x-axis within our limits so that we can calculate areas above and below and take these into account. Then we have to integrate it between our limits and do ourselves a pair of definite integrals, or even more than just two. All depends on how many times it crosses the x-axis, how many roots it has. So the first thing we have to do is solve it for the roots. So remember, when solving for roots of an equation, we set it equal to 0 and we factorise. So in this case, we take x cubed minus 6x squared plus 11x minus 6 and we set it equal to 0. So to solve this, we have to factorise it. Now, factorising x cubed minus 6x squared plus 11x minus 6 gives us 3 roots. So I get x minus 1, x minus 2, and x minus 3 when I factorise it, and that equals 0. So I know then I've got 3 roots. So I've got x equal to 1, 2, and 3. So if I was to sketch the curve, so just do a rough sketch of it, I know that it would look something like that. So it would go up, cut down between 2, cut back up between 3, and shoot off to infinity. So what I've got to do, if I want the area between 1 and 3, so this whole section here, I'm going to have to do the area here and the area here in 2 separate integrals and then combine them. So to get my total area, I have to do the integral from 1 to 2 of it, then I have to do the integral from 2 to 3. Once I've done both of those, I combine them together. So for the first one, I'm looking for the integral from 1 to 2 of my function x cubed minus 6x squared plus 11x minus 6 dx, so with respect to x. Now remember our steps when integrating a function. We take our power, we raise it by 1, we divide by the new power. So x cubed becomes x to the 4 over 4, take away 6x cubed over 3 plus 11x squared over 2, take away 6x. And we then know that that's between our two limits, 1 and 2. So now that we've got it, we just simply substitute in our limits, calculate the two parts, and then calculate the difference between them. So I start by substituting in the 2. So I get 2 to the power of 4 over 4, take away 6 times 2 to the power of 3 over 3, plus 11 times 2 squared over 2, take away 6 times 2. We then substitute in the 1 for our second bracket, and I get 1 to the 4 over 4, take away 6 times 1 cubed over 3, plus 11 times 1 squared over 2, take away 6 times 1. So now I need to simplify both brackets and then combine them by doing the subtraction. So, first bracket, 2 to the 4 over 4, well that's the equivalent of dividing by the 4, so I get 2 squared, so I get 4. Take away, well 6 times 2 cubed over 3 is the equivalent of 2 to the power of 4, which is 16. Plus 11 times 2 squared over 2 gives me 22. Then it's take away 12. Then my second bracket comes from this, so 1 to the power of 4 over 4 just gives me a quarter. 6 times 1 cubed divided by 3 gives me 2. 11 times 1 divided by 2 gives me plus 11 over 2. Then it's minus 6 for my 6 times 1. So now I need to simplify both brackets and just calculate the difference. 4 take away 16 gives me minus 12, plus 22 gives me 10, take away 12 gives me minus 2 for the first bracket. It's then take away, so a quarter minus 2 plus 11 over 2 minus 6 ends up giving me negative 9 over 4. So minus minus becomes a plus, so I get negative 2 plus 9 over 4 That gives me a quarter. So the area here is a quarter square units. I then do the same for this one, calculate the integral here. Once I've done that, I then take my two areas and add them together to get the total area underneath the curve. So integral from 3 over 2, it's the same function, x cubed minus 6x squared plus 11x minus 6 dx. Integrate it, I get the same answer when I do the integral, so I get x to the 4 over 4, take away 6x cubed over 3, plus 11x squared over 2, take away 6x. This time though, the limits are not 1 to 2, they're 2 to 3. Same idea, substitute the upper, substitute the lower, find the difference. So I get 3 to the power of 4 over 4, take away 6 times 3 cubed over 3, plus 11 times 3 squared over 2, take away 6 times 3. That then is take away the second integral at my second limit, so 2. So I get 2 to the power of 4 over 4, take away 6 times 2 cubed over 3, plus 11 times 2 squared over 2, take away 6 times 2. Now I've actually already done this one. This was my upper limit here, remember. So I actually know that this already gives me negative 2. So I don't need to worry about calculating this one. It takes away a bit of the maths that's needed. I just need to look at this bit here. So 3 to the power of 4 over 4, that's 81 over 4. Take away 6 times 3 cubed over 3. Well, that's the equivalent of 6 times 3 squared. 3 squared is 9. 6 nines are 54. Plus 11 times 3 squared. 11 times 9 is 99 over 2. Take away 6 threes, which is 18. And that's then minus the negative 2 from this second part here. So the first bracket, 81 over 4, take away 54, plus 99 over 2, take away 18. Combine all that together, I get negative 9 over 4, take away negative 2. Minus minus becomes a plus, so it's negative 9 over 4 plus 2, which gives me negative a quarter. So my whole area, the entire place, is this area plus this area. Now remember, the area below is giving me a negative value. So in order to take the size of it, i.e. the area, I ignore the negative and I know it's a quarter unit squared. So therefore my total is equal to the first area, so a quarter, plus a quarter, so it's a half units squared. So that's the entire area there, half units squared. So we don't know the units, so we just say that. Second question was y equals x cubed minus 6x squared plus 8x. Again, first thing we have to do is find the roots. So we've got x cubed minus 6x squared plus 8x equal to 0. Factorise it, you get 8 bracket x minus 4, x minus 2 equals 0. So from that I get roots of x equals 0, 4 and 2. So if I was to sketch the curve, it's a very rough sketch, something like this. There's my first root at 0, my second at 2, my last one at 4. And I want the total area here, so again, same sort of steps. Area of the first bit, area of the second bit, and we combine them. So the first one is the integral from 0 to 2 of x cubed minus 6x squared plus 8x dx, all with respect to x. What I then do is take my upper limit, my lower limit, and substitute it in after I've integrated it. Remember that key fact. So when I integrate, I get x to the power of 4 over 4, take away 6x cubed over 3, plus 8x squared over 2, and it's between my limits, which is 0 and 2. So let's substitute in the upper limit first, then the lower. So I get 2 to the power of 4 over 4, take away 6 times 2 cubed over 3, plus 8 times 2 squared over 2. It's then take away the lower limit, which is 0 to the 4 over 4, take away 6 times 0 cubed over 3, plus 8 times 0 squared over 2. Now the good thing about this last one here everything becomes 0. So 0 to the 4 is nothing, 0 cubed is nothing, 0 squared is nothing. This one just drops out because it equals 0. So we only have to really worry about the upper limit. So 2 to the power of 4 over 4 ends up giving me 2 squared, which is 4. It's then take away 6 times 2 cubed over 3. Well, 6 divided by 3 is 2. So that then essentially becomes 2 to the power of 4, which is 16. 8 times 2 squared over 2. The 2 of the 2's cancel, which gives me 8 times 2, which is plus 16. So 4 minus 16 plus 16 gives me 4 units. So that's the area of this section here. I then need to do the section here. So this one here, I get by doing the integral from 2 to 4 of the same function. I've got x cubed minus 6x squared minus 8x dx. So I do the exact same integral, the exact same function, the only difference being my limits. So again, it's x to the 4 over 4, take away 6x cubed over 3 plus 8x squared over 2 from this time 2 to 4. So substituting the upper limit, I get 4 to the power of 4 over 4, take away 6 times 4 cubed over 3 plus 8 times 4 squared over 2. Then it's take away the lower of the two limits, which is 2 to the power of 4 over 4 minus 6x cubed over 3 plus 8 times 2 squared over 2. Now this one here, the lower limit, actually we know that already. It's this part here, which is 4. So I know that that equals 4. I don't need to worry about mucking around with that calculation. I can just stick to my upper limit, calculating that and then combining it with this one. So 4 to the power of 4, well that's essentially the same as doing 4 cubed. 4 cubed gives me 64. So then take away 6 times 4 cubed. So take away, well 6 divided by 3 is 2. 4 cubed is 64. So 2 64s are 128 minus 128. My last one is then 8 times 4 squared over 2. Well, 8 over 2 is 4. So that then is essentially 4 cubed. 4 cubed is 64. It's then take away the 4 that I get from that. Well, this one here, 64 plus 64 minus 128, that's 0. So my area for this one becomes negative 4 units squared. But we have to remember, it's underneath the axis, it's going to give me a negative area. So to do the overall area, I ignore the negative, so I get 4. Then I could say that my total area is equal to the upper one, which is 4, plus the lower one, which is 4. So I get 8 square units. We have to remember that. This is key how we do it. If it's above and below the axis, we do each part separately, combine the whole spiel at the end. Just remember, if we get a negative area, which we will for the parts that is under the x-axis, we ignore the negative sign and we take the positive value for the area to then combine it. Remember that fact, we cannot have a negative area overall. You can't have something taking up negative space. It has to be a positive value, so we have to remember that.